So in this video we're going to take the scientific notation of a very small number and we're going to change it into its standard form. So when we have these negative exponents, we're going to move our decimal to the left, which is different from when we had the positive exponents where we were moving them to the right. So in this case, here's my decimal here between the 1 and the 3, and I'm going to move left 3 places. So 1, 2, 3, and so that's where my new decimal is going to be. And in each of these little loops or U's, I'm going to put zeros. So then when I rewrite this, I'm going to have 0.00132, and that is the standard form of what we have up above. So here's the scientific notation, there's the standard form. We're just moving, if I have a negative exponent, I'm going to move to the left. So I'm going to write the following in the standard form. We have 1.23 times 10 to the negative fifth. So the negative fifth means I'm going to move to the left 5 places. So this would be 1, 2, 3, 4, 5. So this is my new decimal, and in each of these little U's I'm going to add a 0. And so I end up with 0 point, and now I have 4 zeros. 1, 2, 3, 4, and then 1, 2, 3. And then that is my answer in standard form. So that's how standard form works. And now we're going to do one of our real-world applications. But before, silly me, before we do that, we're going to review ratios. So real quick, remember that we can write ratios in one of three ways. That we could write it as A to B, or A colon B, or the most mathematical way you're going to see it so that we can use it, A divided by B. And so this fraction is going to be the way that we write ratios for our homework. So when we get to example 3, the length of a cell A is 8 times 10 to the negative fifth meters. The length of cell B is 0.1, 2, 3, 4, 5 zeros, 4 meters. So we want to find what the ratio of cell A is to cell B. So what that means is I'm going to put cell A divided by cell B. Now, in order to more easily do this, I'm going to change cell B into standard or into scientific notation. So I know cell B is going to be 4 times, and then 1, 2, 3, 4, 5, 6. So 10 to the negative 6. And so then from here, I am going to put cell A over cell B. So we're going to have 8 times 10 to the negative 5 divided by 4 times 10 to the negative 6. Now, when it comes to this we're going to use what we learned in chapter 3. So I'm going to take 8 divided by 4, and that's going to give me 2. And then when it comes to my exponents, so we'll write this off to, actually, we'll write it right here. So we did 8 divided by 4, and then I'm going to take that times, and we're going to do 10 to the negative 5 divided by 10 to the negative 6. So when we divide, we actually subtract. So far we got 2 times 10. And so I'm going to do negative 5 minus a negative 6. So that becomes negative 5 plus 6, which equals 1. So that is the same as 2 times 10, which equals 20. The ratio of cell A to cell B is 20. or 20 to 1 or 20 over 1 since it's a ratio. Now, is it easier to find this in scientific notation or standard form? If you wanted to, you could have changed cell A to 0.00008 and done the division from there. Now, in my personal opinion, it is easier to take 8 divided by 4 and to do the subtraction with the exponents. Really, part B is it could be your own opinion. But honestly, this could go much faster. Because you're not having to type, you're not having to worry about, did I get the right number of zeros in? Do I need to double check my zeros? It really is just division and some simple subtraction. So, in my humble opinion, scientific notation is the easier one to use because you can make fewer mistakes with it. And then that is the end of section 3. Until next time.